Sensor fusion is the process of combining sensor data or data derived from disparate sources such that the resulting information has less uncertainty than would be possible when these sources were used individually. Understand this sentence very carefully. Sensor fusion is nothing but process of combining the sensor data. Now there are various sensors like camera, radar, ultrasonic sensors which you already know. So data from all these sensors will be coming individually, and individual data will carry lot of uncertainty. So by combining the data from all these various sensors, the uncertainty will become very less. That's what this sentence is clearly explaining. And it is not possible for each sensor to work independently and deliver all the information needed for an autonomous vehicle to operate with highest degree of safety. Not just the uncertainty, it is in the safety perspective also, it is not safe for the vehicle to take the data exclusively from one sensor. That is the reason multiple types of sensors together allows autonomous driving systems to experience the benefits of sensors collectively while offsetting their individual weaknesses. Autonomous vehicles process sensor fusion data dependent on algorithms programmed. This allows self-driving vehicles to form judgments to take the right decision. This is simple common sense. More data you have, more data you perceive, better the self-driving vehicle can take a judgment, or better more the data, better the judgment. Okay, now autonomous driving systems use four core machine learning functions to continuously understand their surroundings, make informed decisions, and predict possible changes that could intervene with the route. Driving automation is accomplished through using a combination of autonomous vehicle technologies and sensors. Detect use of camera, lidar, and radar sensors to obtain information on the external environment such as free driving space, obstructions, and future predictions. Segment. Now, second methodology is segmentation. With the detected data points, alike points are clustered together to identify categories such as pedestrians, road lines, and traffic. So first you detect, then you segment and cluster together. And after you cluster, what do? You classify. Use the segmented categories to classify objects that are relevant and rule out those that are irrelevant for spatial awareness. So you classify the relevant objects, and an example is identifying available space in the moment on the road to drive without accident. Now after classification, what do? You monitor. You continue monitoring relevant classified objects within the local vicinity to predict the next action through the entire journey. Okay, so these 4 points, detection, segmentation, classification, monitoring, are the basic building blocks of the sensor fusion. Now sensor fusion is the ability to bring together inputs from multiple radars, lidars, ultrasonic cameras to form a single model or image of the environment around the vehicle. Now this is something which I already explained. All right, so have a clear understanding what exactly sensor fusion. Now basically there are three types of sensor fusion. One is abstraction level, where the question when should fusion occur is answered, and next is centralization level, where the question is where. Here you answer where is the fusion happening, and in the computation level you ask what should the fusion do or what is getting fused. Understand this picture very carefully before you listen to the explanation. You please see this illustration very carefully. In the abstraction level there are three types: low level fusion, where you fuse the raw data, and mid-level fusion, where you fuse the object detection. Now I already explained what is meant by detection in the previous slide. And also high level fusion, fusing the tracks. Now next this fusion is centralization level, and centralization level is again bifurcated into three types, which is centralized, where one central unit deals with the fusion, where one central unit deals with the fusion. Let me point out, explain pictorially. Let me take a pen. Now this is the centralized fusion, where the data from all the three are coming together. Next is decentralized, where each sensor fuses data and forwards to next one. Here, like a permutation combination, camera fuses with the radar, radar fuses with the ultrasonic sensor, and this combination is again sent to a decentralized unit. Now this is called decentralization, and next is distributed. Now here again the various permutations and combinations of camera and radar are combined together, and all the combined data are sent to one distributed function. Okay, so please understand this abstraction level and centralization level are the two most important aspects which are required, or two more important procedures through which fusion is made. And next is competition level. I am not going much into competition level because that is not important, it is not exactly very relevant. The way forward for sensor fusion and perception. To accelerate the sensor and autonomous driving adoption, sensor fusion and perception solutions must provide the requisite performance, flexibility, scalability, and reliability. So once the data is fused, the data should have the following four properties, which is it should perform well, it should be very flexible, it should be scalable, and it should be reliable. Alright, now what is performance? Higher autonomy levels demand higher levels of accuracy and precision in the object detection. Now this is common sense. The higher the level of autonomy which is required, the better, the more precise, the more accurate data should be present. And the preferred technique to achieve this is the raw data sensor fusion, which combines raw data from all the available sensors on the vehicle, provides rich data for a perception system to accurately detect and classify an object. Flexibility. While traditional and existing perception solutions are camera centric, future perception solutions need the capability to incorporate other sensor architectures on the same platform based on the level of autonomy desired. Now understand the meaning of this flexibility. So as the autonomy is increasing, the level of autonomy is increasing, the architecture should be capable of adding new sensor architectures on the same platform. So preparing a platform for every sensor architecture is next to impossible. So it should be very flexible. The next important property is scalability. Vehicles with varying autonomy levels should coexist as ADAS and autonomous driving continue to evolve in the future. So, ability to build a sensor and scale it from L2 level to L5 level on a common platform, and also to ensure consistency in the technical specifications and product quality is a mandatory prerequisite. I hope you understand the importance of scalability. Last but not the least, it must be reliable. Confidence in autonomous solutions is based on safety and performance. Sensor fusion and solution must pass stringent quality and performance requirements.